I want to talk about some special properties of the sine and cosine. And for that, I want you to remember, if you can, our definition for sine and cosine. That if we have an angle, it's called the angle theta. So if we have an angle theta, here, let me draw the triangle first. It's a right triangle. So this is a 90-degree angle right here. Here's our angle theta. Then we say that if we say this sine is y, and this side right here is length x, and we've been calling the length of the hypotenuse r because we relate it frequently to the radius of a circle. We say that the sine of theta is equal to y divided by r, and the cosine of theta is equal to x divided by r. Now, if you recall that in a right triangle, that the hypotenuse r is given by the square root of the sum of the squares of the other two sides. So it's a square root of x squared plus y squared. That's r. Or we could also write that r squared, the Pythagorean theorem tells us that r squared is equal to x squared plus y squared. Okay, so because r squared is equal to x squared plus y squared, we know that r squared is always going to be greater than x squared, and it's also always going to be greater than y squared. In other words, let me write that down. We know that r squared will always be greater than or equal to x squared. Why is that true again? Because r squared equals x squared plus y squared. Now the square of any number must always be greater than 0, even a negative number, right? You know, for example, that negative 2, if we square it, is equal to 4. The square of any number is always greater than or equal to 0, with 0 squared equal to 0. Okay? So r squared is always greater than or equal to x squared, and r squared is always greater than or equal to y squared. Because of that, I can say that this implies here that the r will always be greater than or equal to x. In other words, this side of the hypotenuse is always greater than or equal to x, and r is always greater than or equal to y. Now you remember we also talked about the theorem in geometry, which says that the sum of any two sides of a triangle will always be greater than the third side. So that's telling us that x plus y is always going to be greater than r. It will equal r if everything lies on the same straight line, which isn't really much of a triangle. And if this is true, okay, so remember this. This is similar to this, but not quite the same. Here we're saying that r is greater than or equal to x, and r is greater than or equal to y, but here we're saying that x plus y is always greater than or equal to r. All three of these statements must be true for any triangle. Now, if r is always greater than or equal to x, and cosine is equal to x divided by r, got my equal sign there. Cosine is equal to x divided by r, and r is always greater than or equal to x. That's telling me that the cosine must always be less than or equal to 1. So this right here, okay, together with this tells me that the cosine, so these two together, bring them down here, tells me that the cosine of theta must always be less than or equal to 1. And this right here, together with this, tells me that the sine of theta must always be less than or equal to 1. Okay, so both of these statements are true all the time and are properties of the sine and the cosine. So we have r squared is equal to the square root of x squared plus y squared. We have that r squared must always be greater than or equal to x squared. Tells us that r is always greater than or equal to x. That tells us here that cosine is always less than or equal to 1. Similarly, we get r is always greater than or equal to y, which tells me that sine must always be less than or equal to 1. Now, in fact, both of these statements can be expanded a bit because it is possible for sine and cosine to take on negative values, and which we'll talk a little bit more about, and we've already talked about that a little bit. But it turns out to be true that the absolute value of sine of theta must always be less than or equal to 1. And it turns out also to be true that the absolute value of cosine of theta must always be less than or equal to 1. Now, one more thing before I close this discussion. And that has to do with the fact that because the hypotenuse squared is equal to x squared plus y squared, and we look at our right triangle, so here's our right triangle. Okay, if this is side y, oh, this is side y right here, this is side x right here, and this is side r right here, we know by the Pythagorean theorem that this squared plus this squared is equal to r squared. X squared plus y squared is equal to r squared. That's what I have right here. Now we know if we divide, let me divide through by r squared. If I divide this expression by r squared, I get r squared divided by r squared is equal to x squared plus y squared divided by r squared. That's equal to x squared divided by r squared plus y squared divided by r squared. Then this is equal to x divided by r, the whole thing squared, plus y divided by r, the whole thing squared. But you remember we have x divided by r is equal to cosine of the angle, say cosine theta, where this is angle theta right here, and y divided by r is equal to sine of theta. Okay, so that means we have this equal to that, we have this equal to that, so this is equal to cosine squared, cosine, oh, cosine theta squared plus sine theta squared cosine squared plus sine theta squared, that's what this is equal to. And over here, when I do r squared divided by r squared, that's equal to 1. So I have that 1 equals cosine squared plus sine squared. And usually we write cosine squared and sine squared in the following fashion. I'll say cosine, and I'll write a little squared here, cosine squared theta plus, and I write this as sine squared theta. So this is the customary way of writing this. So here's our result, that cosine squared theta plus sine squared theta equals 1. Okay, that's an important result, which we will use many times in mathematics. Okay, thank you.